In this question, we have two orders traveling. One is traveling to the right and another one is traveling to the left. The one that is traveling to the right goes with 6 meters per second and it has a mass of 5.75 kilograms. The one that travels to the left goes with a velocity of 5 meters per second and it has a mass of 7.5 kilograms. In the first item of this question, we have to determine what is the velocity of both otters after the collision. Note that after the collision, they will be traveling together. To solve the first item, you have to remember about conservation of momentum. That law says the following: the net momentum of the situation is conserved, either before and after it's the same. So we can say that the net momentum before, let me call this Q net, is equal to the net momentum after the collision, which I'm calling P prime net. Now, I will choose a reference frame. In my reference frame, everything that is pointing to the right is going to the positive direction. Now, note that the two otters are traveling initially, but one otter is traveling to the right and another one is traveling to the left. Meaning that this otter, which is traveling to the right, will have a positive velocity in my reference frame, and this otter that is traveling to the left will have a negative velocity in my reference frame. Okay, now let's calculate their momentum. The momentum is given by this equation. So we can say the following. Before the collision, we had this otter with a mass of 5.75 kilograms traveling to the right, so with a positive velocity of 6 meters per second. And we also had another otter that is traveling to the left, so it has a negative velocity, and then we get a minus sign here. It's traveling to the left, but it has a mass of 7.50 kilograms, so we have 7.50 times the velocity, which is 5 meters per second. And then, after the collision, both otters will travel together with the same velocity, which I'm calling v. Okay, so after the collision, the net momentum is given by the mass of the two otters times the velocity of the two otters. So to solve the first item, all we have to do is solve for v. So v is equal to 5.75 times 6 minus 7.50 times 5 divided by 5.75 plus 7.50. And this results in a speed of approximately minus 0.226 meters per second, meaning that after the collision, the otters will travel to the left because of this minus sign with a velocity of 0.226 meters per second. And this is the answer to the first item. In the second item, we have to determine the amount of dissipated mechanical energy in this situation. So all we have to do is evaluate the kinetic energy before and the kinetic energy after, and then compare both of these energies. Before the collision, we had a kinetic energy that I'm calling EK, and that energy is given by the sum of the kinetic energy of this otter with the kinetic energy of this other otter. Okay, the kinetic energy is given by this equation. So we have the following. The kinetic energy of this otter is given by its mass, which is 5.75 times the velocity squared. Then we add the kinetic energy of the other otter, which is given by its mass, 7.50 times its velocity, 5 squared. Notice that I'm not plugging in the minus sign here because we are squaring the velocity anyway, so that minus sign will make no difference in the end. Then, after the collision, they have a kinetic energy EK prime that is given by 1/2 of the total mass, 5.75 plus 7.50 times the final velocity squared. Then we have 0.226 squared. So that the variation in the kinetic energy is given by the final kinetic energy, 1/2 of 5.75 plus 7.50 times 0.226 squared minus the initial kinetic energy, which is 1/2 of 5.75 times 6 squared minus, because we had plus, so minus 1/2 times 7.50 times 5 squared. This results in a variation in the kinetic energy that is given by approximately minus 197 joules, meaning that 197 joules of energy were dissipated in this situation.